Welcome, ladies and gentlemen. Welcome to the public forum at our group exhibit, Hydrogen Fuel Cells and Batteries. It's now all about improving fuel cell economics with low-cost catalysts. And I'm very happy to have here with me for the next interview the chairman of Pajarito Powder from Albuquerque, New Mexico, United States, Tom Stephenson. Here he comes. Good to have you here, Tom. Please sit down.
Good to see you. Good to be here.
So that's going to be a discussion and interview, and whenever you have a question, please raise your hand. I'll be with the microphone right with you, so you can ask your question whenever you want to. Tom, I just said you're from New Mexico, from Albuquerque.
Yes.
You're from the chemistry. You have something to do with chemistry. Make sure, just to make that sure, it's your product is not blue and it's totally legal, is it?
It is indeed totally legal, and so. The fact that they've filmed the Breaking Bad show there has obviously become global in its reach even more than national. But yes, everything we make is legal. It's not blue. It's black powder. But it is chemistry related. So.
Very good to hear indeed. Okay, we are here at the world's biggest exhibition and marketplace for fuel cells. And as far as I've learned in the next years, there are only three problems about fuel cells, which are costs, costs, and costs. Is that true?
We agree. I mean, and so clearly, if you look at the market adoption of fuel cells and fuel cell technologies, the economics associated with that are one of the critical steps that have been preventing more widespread market adoption. And as you boil that down to the components associated with the fuel cell, one inescapable conclusion is that the nature of precious metals, and platinum specifically in the catalyst for PEM fuel cells, is something that cannot be eliminated. It's a cost that can't be eliminated simply through scale. And so there need to be alternative catalysts that allow you to change those economics fundamentally, and that's what we're trying to do with Pajarito Powder.
So a PEM fuel cell needs a catalyst to run,
yes.
Run at high efficiency, and the catalyst needs platinum. How much is platinum at the moment? Do you know the prices?
So the spot prices of platinum are running anywhere from $50 US, $60 US per gram. And that's just for the raw material of the platinum. Typically, one of the things that the industry has done an excellent job of over the course of the last 20 years has been trying to do the platinum thrifting to reduce the amount of platinum. But as the processing complexity has gone up, what's happened is that those catalyst costs then go up. And so the fact that the platinum is only $50 to $60, again, US a gram, the catalysts themselves may run $100 to $200 a gram.
That's right. So if you go to large scales of producing PEM fuel cells, well, the demand will be higher, and as we all know, then the cost will go up as well. So what are the percentage of a stack for the platinum catalyst in it?
Well, it varies quite a bit depending upon the configuration of the particular fuel cell stack, but generally you talk about 20% to 40% of the fuel cell stack cost actually comes from the catalyst. And to your point, even if the platinum costs remain stable over time, as the economies of scale continue to drive down the other costs of the components, that percentage that's associated with the catalyst, and specifically with the precious metal in the catalyst, will continue to rise.
So Tom, you're the world's first commercial manufacturer of drop-in replacement non-platinum fuel cell catalysts. What do you mean with drop-in replacement?
So our goal when we started Pajarito Powder was to have a catalyst formulation that fuel cell stack manufacturers could use in the same way that they use platinum catalysts today. And so when we talk about a drop-in replacement, what we're talking about is something that can be manufactured into an MEA in the same way that platinum catalysts can, and therefore become part of the same fuel cell stack architecture without having to significantly re-engineer your fuel cell stack and system.
So what you're selling is kind of powder. It's not a sheet in the stack.
No, it is a black powder.
Yes.
And we have samples at our booth if anyone's interested.
Okay.
But it's just a black powder that looks the same as the platinum loaded catalyst that then gets put onto the MEAs in the same way.
So you don't have to change the structure of the stack itself, but you have to change the catalyst, don't you?
You do. You would swap out the catalyst and replace it with ours. There are a few differences in the manufacturing processes. Of course, not everything is exactly the same. But the good news is that for our MEA manufacturer partners, it's the same set of equipment. It's the same set of processes that allow them to lay down the catalyst on the MEAs in the way that they do today.
And as you said, it's a black powder. So I guess it's some kind of carbon, isn't it?
There is carbon involved, yes.
Okay, you wouldn't talk much more about the material. It's all confidential, isn't it?
I'd need a whiteboard and a higher chemistry degree than I have in order to be able to do that. So I'll defer that one to the CTO.
Okay, very good. So it is available, obviously, because you brought it with you. You can buy it right now. Well, you didn't bring the amounts of this material, but you take orders, don't you?
We do, absolutely. Our flagship product, which we call the 2000, which is a completely platinum-free catalyst, is one that we have available for purchase today. So if people make a purchase order, then depending upon the quantities, then we can have it in their hands in a lead time of a week or two.
So in comparison to the platinum, how much money can I save by using your material?
Well, one of the things that I think is sort of interesting when you talk about the improvement in the economics of the fuel cell as a whole is that you do have to recognize that non-platinum catalysts do not have the same activity level as platinum catalysts, and we're not representing that. And so the biggest change that goes on for the fuel cell system manufacturer, the fuel cell stack manufacturer, is in understanding what the potential changes are in the power density that comes from that. When you talk about the sort of straight apples to apples comparison of just catalyst costs, then we talk about a very small fraction of the cost of our catalyst when you compare it to the platinum catalyst, but there are going to need to be some changes to the size of the fuel cell stack or system, which in some cases is not a problem depending upon the particular application and the power density demands that the customers have.
Okay, so there are some disadvantages, of course. The big advantage is less cost, but also less performance. How much less performance? Can you say that in numbers?
Sure, and so one of the things is that it will vary upon the particular operating conditions, and right, it's that there's always a caveat to the answer, right, before I actually give you the answer, which I will try to do, but in general we're looking at at non-platinum catalysts that have performance ranges that are in the sort of 20 to 30% of the activity level of platinum. Comparable in durability, comparable in stability to platinum, but with those lower activity levels.
Okay. What about durability? Is it as good as platinum catalysts?
The durability matches to the durability levels that we see within platinum catalysts, yes.
And reliability, what about that?
Again, the same.
Yeah.
Well, we have somewhat limited data in terms of long-term testing in fuel cell stacks, but in terms of the accelerated testing protocols that we've run, we see the exact same set of phenomenon go on and very similar reductions in the overall performance curves for the non-platinum catalysts as we do for platinum catalysts.
Tom, when you say you have less performance with your material in the catalyst, maybe there's an opportunity to mix it, to have a little bit of platinum and a little bit of your material, and then you get the right mixture.
Well, that's exactly right. The right conclusion to come to as we came to the same one, which we sort of joke about sprinkling a little bit of platinum on top of it and see what that does. But we do now
Adding
have
a little salt to the
right,
meal.
exactly. Add a little salt to the meal and it fixes it up. But we do now have, and we're just sampling this to customers. It's not available commercially yet, but our platinum hybrid catalysts, which use ultra low loadings of platinums. Because ultimately, when we started Pajarito Powder, our goal was to be able to fundamentally alter the economics associated with catalyst production for PEM fuel cells. And it's not about necessarily is there platinum, isn't there platinum in most cases. It's about what is the cost for the customers. And so we have that ability to fine-tune the manufacturing through either a completely platinum-free catalyst or through one that has very low levels of platinum content to be able to reach different levels of activity based upon wherever the customer wants to be along that sort of cost-performance trade-off curve.
I would like to invite you, if you have any questions, just raise your hand. We'll be right with you with a microphone. You can ask your questions right away. Just a moment. Please introduce yourself.
I'm Debashish Chakraborty from Technical University of Denmark. I just have a question about the catalyst you are talking about. Is it the anode or the cathode catalyst?
Cathode catalyst.
It's the cathode catalyst.
Our focus has been on oxygen reduction cathode catalyst for PEM fuel cells, right?
Okay, thanks.
Thank you very much for that question. Any more questions? Not at the moment. So, Tom, we are talking about 3 different products that you have in the pipeline. 2 of them already available to order. The third
That's
one
correct.
you're just talking about. What are the 2 ones?
Right, so we have our core product, which is the 2000 product. We have what we call a 1000, which actually has a lower performance level that is at an even improved cost point, substantially improved cost point, and that's really for folks that have the lower power density requirements associated with their fuel cells. So the 3 levels of products, the 2000, which is our core product, the 1000, which is the cheaper non-platinum catalyst as well, and then the 3000, which is actually a hybrid between the 2000 with small levels of platinum included in it.
I believe we are talking about, a little black powder, but this could change the whole industry, don't you think so? Because to bring down the cost of fuel cells is most important for applications of fuel cells.
We certainly like to hope so, and we recognize that this has been an issue that the industry has recognized for some time in terms of being able to sort of change that cost structure, and because we've seen potentially the limits of what platinum thrifting by itself can do, that we still need to make improvements in the overall economics of the fuel cell. The catalyst is going to be one of the ways to do that, and it is our hope that by having a product that is platinum free, where our performance is improving all the time, that we're in a position to ultimately help enable far greater and far more rapid market adoption of fuel cells in a number of the applications where they're already taking hold.
So we've been talking about scaling up PEM fuel cells, which would make the platinum more expensive. What about your product? In the end, can you scale up the amount of your product?
So the really good news is ours gets cheaper as we make more of it.
That's good, indeed. Good to hear that.
Very good economies of
You
scale.
have a strong investor behind you, haven't you? It's from the chemical industry.
We have a regional venture capital fund that is our primary investor that is invested in the company based in Albuquerque, New Mexico. Yeah.
Okay, so go ahead, order your material, of course. I can't believe you don't have any competitors. I know there are some research institutes working on non-platinum catalysts. Aren't there some financial commercial competitors in the market?
When you talk about sort of drop-in replacements for platinum catalysts, there really aren't in the industry today. There's nobody that you can call up and say, I'd like to order a kilogram of non-platinum catalyst for my fuel cell system, and our expectation, of course, is that that's going to change over time. There's certainly a lot of people who are working on it, but what's exciting about the progress that has gone on at the research level academically over the course of probably the last 5 years is there have been some very significant breakthroughs that have altered the activity levels to start to get these non-platinum catalysts to the point that they really are finally viable as a potential alternative in some of the applications, and that's what drove us to then start the company and say that next step is to take the academic research, which typically is making things in very, very small quantities, and actually demonstrate that it's commercially viable, build a plant that's capable of producing a kilogram of material, and be able to have that we can sell to customers.
So when you really come to cheaper prices for PEM fuel cells, where do you think where will be the applications, where will be the breakthrough for PEM fuel cells then?
Well, I think that there's no question that there continues to be a tremendous amount of interest and focus on the motive applications, and that's one of the places where fuel cells can really service that industry in a way that no other technology can. But in terms of some of the economics, I think we're seeing a tremendous amount of growth in stationary and backup power, and for our particular products, we believe that's where some of the early entry points are likely to be, since you don't have some of the same issues with the higher power density that you have to have. The automotive application is a very, very difficult one to solve. And so as we continue, particularly when there's the prospect of sort of fundamentally changing the economics over time, then we'll be able to build more of those in some of those industries that may be less sensitive to the power density, and build up increasing expertise, increasing volumes that get us to the point that start to make it more feasible ultimately to get to cars.
And did you test your materials also in electrolyzers, in PEM electrolyzers?
They don't work for electrolyzers,
right,
unfortunately.
okay.
So we did. This is a fuel cell application, and one of the things that's interesting about the non-platinum. I mean, platinum is an amazing element, frankly, because it works so well across so many different applications as a catalyst. And when we're trying to replicate that with non-precious metal catalysts, there is a lot more to the specific formulation. And so, the good news is that we can tune the catalyst formulation that we have depending upon if you're operating at 0.6 volts or 0.7 volts or what your overpressure looks like and so forth. But the bad news is that there's a limit to that, which means that if you're running an electrolyzer, it's just going to break down. It's not suitable for that. And a lot of the other applications, it's very targeted at the cathode for the oxygen reduction reaction, and that's what we've really specifically targeted the product to do.
Okay, but the good news, of course, is PEM fuel cells will become cheaper with your
Absolutely,
product, which
yes,
is very
and it's
good.
cheap.
And for all of you who are more interested to discuss with Tom, he can visit you at your booth, which is at D80/1, just near the
Absolutely.
technical forum. Please go and visit him at his booth. I would like to thank you, Tom, very much for this interesting
you,
talk.
I
Wish you
appreciate
good
it.
luck with your product, and thank you very much for your attention.
Thank you.
you, gentlemen.
Thank you very much.